Hello everyone, welcome to the second part of Chapter 1. This section is really talking about the science of psychology, which is how we do our research in psychology. Again, this is a subfield that you would spend time learning when you go on into a class for psychology. Hello everyone, and welcome to the second part of Chapter 1. And today we're going to be talking about the science of psychology, which is really all about how we do our research in order to learn about psychology. So research in psychology. And there are many specializations in psychology, as we talked about before. There's even art psychology, how we create art for therapeutic purposes. Developmental psychology, how do we develop emotionally and socially, intellectually over our lifespan. Neuropsychology, I told you that's what I am, a neuropsychologist, how the brain affects your behavior. Sports psychology, many subfields. And all of these specialties use research and statistics. So if you decide to go into psychology as your major, you will have to take a statistics and a research methods class. Here are just some random titles of different research articles that I found just to show you that there's all sorts of research. So here's a title, Involvement of Fathers in Therapy, a survey of clinicians. Are fathers interactive and do they get involved in therapy? Students' ratings of teachers' effectiveness, a laughing matter. This was a really interesting study about does humor make teaching more effective? Are funny teachers better, basically, than non-funny teachers? Online instruction, are outcomes the same? This is a very important one as we're moving on to so many more online classes. I like this one, relationship between mental toughness and physical endurance. This is Project DARE. This was a drug, Say No to Drugs program, and how effective was that program? Adult helping qualities preferred by adolescents. Adolescents very notoriously don't like help from adults. So what kind of adults qualities do adolescents prefer? So as you can see, there is all sorts of research. I think students sometimes feel that research is boring, but particularly myself as a researcher for many years, you can see that the research in psychology can be quite interesting. Just because I thought I had the opportunity, I put some titles of my journal articles. This is my research that has been published, and I work with children who have had strokes, children who have a metabolic disorder called cystinosis, a very rare metabolic disorder. I work on neuroplasticity in the developing brain. I've worked on studied children who are diagnosed with attention deficit hyperactivity disorder. And so you can see that I use research all the time, research and statistics, and it's actually something I love and love to talk about. So what's the point? 93% of universities require students to take a statistics or research methods class. Why is that? Not just because we perhaps want to bore you, as some of you might think, but we have two main goals. The first is how to conduct good research, and that's important as you move on in a major in psychology or decide to go on to graduate school in psychology. You will have to conduct research. But the other is how to critically evaluate research, and this is important for everyone, even those of you who never plan to take another psychology class in your life. You just have to do this for a requirement. You will always be presented with research findings when you're reading things on the internet or hearing things on TV. They'll present research findings. What about this new medication? What about, exercise, I don't know, is good for your brain, or whatever headlines you're hearing that are based on research articles. And our goal is for you to be able to critically evaluate the research that's being presented to you so that you don't just have to take the headline as the truth. And so again, today is just a small overview of research methods, but you as you would move on in a psychology major, would be taking an entire class on this. And again, here's that. What's the point? Listening to classical music increases your IQ. You might have heard that. Children who eat breakfast do better in school. Smoking is linked to lower grades. These are headlines that came right from a newspaper or magazine. And the thing is, we want you to be a critical thinker. Don't just take this for what it is. Do you think that if you just listen to classical music, that's going to cause your IQ to increase? I mean, if it was that simple, we would all just have classical music in our houses all day long, right? Or do you think that just by eating breakfast, children would do better in school? If you were promised to get, is it just that you eat breakfast and then you get straight A's? No, but there's probably a lot more in the study and a lot more that you could think about as to why children who eat breakfast do better in school, right? Why might that be? And you would want to read into the article. Maybe these are families who are more organized because they wake up in time to cook breakfast. Maybe it has to do with socioeconomic status. These are families who can afford to feed their children breakfast. All sorts of things that might be linked to why children who eat breakfast do better in school. And again, the point of research methods, one of the main points of taking research methods in a psychology major is to be a critical thinker. And so how do we learn about the world? Well, there are two main ways we've learned about the world. You all know quite a lot, and probably none of you have done your own research study. So how do you learn about the world? Well, number one, we use our intuition or our common sense all the time. How do you learn? You kind of just say, well, that makes sense to me. That's your intuition. It just makes sense. And that's one way we learn about the world. Your intuition is not always right. Although don't tell my husband, because I tell him my intuition is always right. But your intuition is not always right. And one of the kind of most common or famous ideas where someone's intuition was wrong was the idea that the earth is flat. For many years, long, long ago, people believed the earth was flat. You might have remembered hearing about this, right? The earth was flat. You could fall off the edge of the earth. Well, why was that? It was people's intuition. If you look down right now at your floor, it looks pretty flat, right? You would never imagine that we're on a round planet. And so people believe the earth is flat, but that certainly turned out not to be the case, not to be true. And then research on interpersonal attraction, right? Do opposites attract, or are more similar people more attracted to each other? Again, you might use your intuition about your own relationships, your relationships of people you know, to be able to say, I think that opposites attract because, you're in a relationship perhaps with someone who's very opposite to you, or your parents are very opposite of each other. Or maybe you think similar people are more attracted to each other because, again, your intuition or your relationships, you say, well, yeah, I'm in a relationship with someone who's real similar to me. So it must be that similar people are more attracted to each other. Again, that's just your intuition. Sometimes it's right, sometimes it's wrong. Another way we learn about the world is by authority, meaning somebody in a position of authority tells you something. So the media tells you something, your teacher tells you something, the government tells you something, someone in a position of authority tells you something. Now, sometimes that is true and is correct information, but sometimes it is not true. In fact, even teachers can be incorrect about what they tell you. Probably a famous example of this one is the tooth fairy, right? Somebody probably told you when you were younger that there's a tooth fairy, that your tooth falls out, you put it under the pillow, and then you wait and a little fairy flies into your house, I don't know, takes your tooth and gives you money. But is that true? Of course it's not true, and I hope I'm not ruining this for anybody who's listening. But someone in a position of authority probably told you that. Probably a parent who is the ultimate authority figure for 5 and 6-year-olds. But again, just because someone in a position of authority tells you something doesn't mean it's true. So how do we know if our intuitions or authorities are correct? Well, we use our intuition and authority as guides for our research ideas. So we don't throw this out entirely. We might say, I think that people who are very similar are more attracted to each other. Now I'm going to do a research study to test and see if that's true. So what is science? Science is really just a process of questioning, of systematically acquiring knowledge about, in psychology, we're talking about behavior, emotions, thoughts, things like that. And science is a way that we formulate our questions and find the answers. And we use what's called the scientific method. You've probably heard that term before. The scientific method is just a process where we first develop a question, then we develop a hypothesis, we design a study and collect data, we analyze the data using statistics, and then we publish the findings. And we're going to go through this. So coming up with our research questions, how do we come up with our questions? This is really all about curiosity and your everyday, again, your observations, your intuition, what you've been told by reading an article or reading a book, by having some kind of interest. And again, while some students might feel like research is just so boring, the idea of research and statistics, and believe me, I felt that way too as an undergrad, it's actually the most creative endeavor I can think of, because really what you do is you have a question, I wonder why this is, you design a research study, you find the answer, and then you do another research study because you've come up with another question. So we come up with our questions just because we're curious about different things. What's the difference between a research question and a hypothesis? Your research question is pretty informal, such as, I wonder if people who are more similar are more attracted to each other than people who are quite different. It's a pretty informal research question. And then we turn that into a hypothesis, a research hypothesis, which is a statement that's used to predict the outcome of your study. And so you would say something like, it is hypothesized that people who are more similar are more attracted to each other than people who are different. That's just a statement that I'm going to use to predict what I think will happen in the study. Now, I may be right or I may be wrong, but I have to come up with a hypothesis. Or I could have just as easily said, I believe people who are very different from each other are going to be more attracted to each other than people who are similar. And then the term theory is important. A theory is kind of the big picture. It synthesizes observations to explain phenomenon. And so we have big theories, kind of like what we were talking about in the beginning of chapter 1. Like, do you have a behavioral theory that it's really most of what you're trying to explain is based in behaviorism? Or is most of what you're trying to explain based in biology? And that would be a biological theory. And then there would be lots of different hypotheses under, let's say, that biological theory that I think that depression is caused by, I don't know, an imbalance of neurotransmitters in the brain. That's a biological theory. I think people are attracted to each other based on their pheromones. That's a biological theory. Right? So these are hypotheses that would all go under a main theory. So a theory is kind of this big general idea, and then we can have many specific hypotheses underneath that theory. When you design a study and collect data, a very important thing is what we call coming up with an operational definition. An operational definition is how you are going to very precisely measure the variable that you want to study. So it's the definition of the variable that's used for your study and how you will measure it, the operations, hence the operational definition. The operations you would use to measure it. So for example, if I asked you right now, who's tired? So we imagine, we have a big class of students out there, and I ask you all who's tired, And I'm going to guess some of you will raise your hand. The problem with that is, are we all talking about the same thing? We all kind of know what tired means, but are we talking about the exact same thing? Probably not. And so we need to take this big idea of, if I'm doing a study about how tired students are as they listen to online lectures, we have to take the idea of tired and turn it from a conceptual definition into an operational definition, meaning how would we measure that being tired for our study? And here's another one, hypothesis. People who exercise are happier. Don't they look so happy? I've never felt that happy when I've exercised. I just want you to know. So we all know what exercise means. We all know what happy means. And we could look in the dictionary even for these definitions, right? Exercise is bodily or mental exertion, and happy means delighted, pleased, or glad. How would we operationalize these concepts? We would need to turn them into something very specific and very precise that we could measure. So how would we operationalize exercise? Well, we might say, we're going to, in our study, have people run on a treadmill 30 minutes a day for 6 weeks. That would be our operational definition of exercise for our study. Or we could say we're going to make people do an aerobics class for an hour a day, 3 times a week for 6 months. Really, it doesn't matter. All that matters is that it is a very precise definition and explanation of how you are going to measure exercise, right? I could say, I'm going to make people, I don't know, run 5 hours a day every day for 3 weeks. That would be horrible. I would not want to be in that study, but that's another definition of exercise. You have to let people know how you're measuring it. And then how would we measure happy? Well, I don't know. We could give people a questionnaire, a happiness questionnaire that they fill out. We could videotape them, have them wear some kind of secret video camera and see every time they smile in a day and count how many times they smile. There's all sorts of ways we could measure happiness, and we need to decide for our study how we're going to measure happiness. All right, so when gathering our data, researchers must remain objective, and the idea is that we're very clear in our definitions, and then we're very objective. We are very, we don't want any bias in our data, and we want to be very controlled in our research. We want to know and treat everybody the same, treat everybody equally, give everybody the same instructions. In this case, we would make everyone do the same type of exercise. So we have a lot of control in our study, and that's very, very important. After we collect our data, we analyze our data using statistics. This is a little bit of a data set out of a statistical program that we use. And if you take a statistics class, you'll learn how to use it, called SPSS. And so we would start making sense of our data. And there are 2 main types of statistics. The first is called descriptive statistics. And this is the first step where we take our data and we just organize it or describe our data using tables and graphs and charts. So we start kind of just looking at the data and describing the data we collected. And then the second step is called inferential statistics, and this is when we make inferences. Again, that makes sense. Inferential makes inferences about how likely the outcome that we found in our study is likely to happen in the future with different people or different situations. Because as you can imagine, if I am doing a study, let's say on some kind of new medication, and I have one group that gets the new medication and one group that doesn't, and the new medication works. It improves whatever the illness was in my experimental group. Well, I really want to know, do I think this medication is going to work for everyone in the world, right? I don't really care about just knowing that it worked on the 50 people in my research study. I want to make an inference. I want to say, because it worked on these 50 people in my research study, I think it will work on other people in the world. And so that's the goal of inferential statistics. Again, you would learn about that in a statistics class. And we'll find out when we analyze our data if our results support our hypothesis. Lastly, we publish our findings. We share our knowledge. It doesn't do any good to do a research study and keep all the data to yourself and not share it. The whole point is we want other people to know if our new medication works, or our new type of therapy works, or if exercise really does make you happier. We want to know these things, and we want to share it with other psychologists and doctors and social workers. And so we publish our findings in what's called a peer-reviewed publication or a peer-reviewed journal. There are journals in all different types of areas of psychology. So there'll be the Journal of Clinical Psychology, the Journal of Neuropsychology, the Journal of Art Therapy. And they're basically like magazines. They come out every month or every couple of months, and you submit your articles, your research findings to these journals. And then they're peer reviewed, meaning other scientists read them, ask you questions. They might ask you to make some changes if they see mistakes. It's kind of like having a teacher correct your paper. And then they're published. And so other clinicians and physicians subscribe to these journals, and they can read your research findings. And then we also present our findings in public at presentations at conferences. So there are professional conferences, and you can go and be a speaker and then present your findings in a public forum like that. And the value of sharing our knowledge, you could think about this, but again, we want to share what we've learned so that other people can use what we've learned to help in their clinical practice and help their patients or their students or whoever it is that they're working with. Of course, we want to be really ethical in this process of publication. You do not want to meddle in your data. You have to take your data for what it is, right? It's not fair to change any numbers, or that's very unethical. And one big example of this was the research on vaccines and autism. That the first study that was done by Dr. Wakefield that found this relationship between vaccines causing autism was a big story and was really publicized all around the world, and parents were very afraid to vaccinate their child for the fact that they were afraid that their children would develop autism. And there were many people who didn't want to get their children vaccinated, and many children have gotten sick because they've gotten the diseases that they weren't vaccinated for. And it turns out that after many years and many other people trying to find this same relationship between vaccines causing autism, nobody else found that result. And it turns out that that first study, the data was meddled with, that it was really just, the data was changed. And in fact, that article has been pulled out of the journal. It's no longer available. It's been retracted. And there is no evidence to show a relationship between vaccines and autism, yet that legacy goes on. There are still people who believe that. And so again, we need to be very ethical in our research, which goes to the importance of replication, meaning that we don't just take one study and then say, oh, that works, or, oh, yep, one study shows a relationship between vaccines and autism, so there must be. We need multiple people to do those research studies. We need replication. We need people to do those studies in other countries and in other groups of people, to see if we get consistent results, that each study is showing this relationship between vaccines and autism. And if not, if only one study shows it, then we start to think, there might be something wrong with that study. And you can see here, and you could pause this if you want to look at it. Dr. Wakefield did that first study, and then we had a study in 1999 of 500 children that found no link. In 2001, a study of 10,000 children found no link. In 2002, you can see, and continuing on, no link to autism was found in any of the studies, and that they had falsified their data. So that is very unethical. All right, more about research. Variables. When we do research studies, we need variables, and a variable is anything, a situation, event, or behavior that varies, meaning it has at least two levels or two values. So if we look here at this example, a sample of registered voters was surveyed. Each voter was asked to first name his or her gender, male or female, then to name the candidate for whom he or she planned to vote, Doe, Jones, or Smith. The purpose was to explore gender differences in voting preference. So we have our first variable would be gender. And then we're giving the choices of male or female, though we call that the levels of the variable. And then the candidate for whom he or she plans to vote. And so that would be our next variable. And we have Doe, Jones, or Smith as our three levels. Now, you can see that there are a number of ways to measure a variable, right? We can have gender be and give the choices of male or female. We could give the choices of male, female, or other. We could give a continuum of male to female, and you place yourself somewhere on that continuum. So there are many ways and many kind of deep critical thinking questions you need to answer as you design a research study. So variable, anything that varies. Variables can take on different values. We have two types of variables. We have what we call the independent variable and the dependent variable. The independent variable is the variable that we think is going to cause a change in the dependent variable. So in a study, we usually kind of are looking at a cause and effect relationship. The cause is the independent variable, or the IV, and the effect is the dependent variable, or the DV. So you could imagine, let's say we're doing a study to see if hours of sleep impacts test performance. And so I have two groups. I have one group that I keep up all night. They don't get to sleep at all. And I have another group that gets to sleep for 8 hours. And then the next morning, I give them all the same reading comprehension test. And I want to see which group does better. So the independent variable, what do I think is going to cause a change? That's hours of sleep. And in this case, I've got 0 hours as one level and 8 hours as the other level. We also call that the manipulated variable because I'm manipulating it as the researcher, and I'm choosing its values. I could do 0 and 8 hours. I could do 0 hours and 4 hours. I could do 3 groups, 0 hours, 4 hours of sleep, and 8 hours of sleep. This is all up to me. And then the effect, or the dependent variable, would be their grade or their score on the reading comprehension test. And we call that the measured variable because that's what I'm measuring. And I'm measuring it in relation to the independent variable. I think scores on this reading comprehension test are dependent on the independent variable, which in this case is hours of sleep. So if we had this question of, does type of class on campus versus online influence students' test scores? What's our independent variable and our dependent variable? Think about this for 1 second, or pause. Our independent variable would be type of class, and our levels are on campus versus online, right? Because this is the cause. And the effect, or the measured variable, would be test scores. Other important terms in terms of research are the idea of a population versus a sample. So a population is all members of an identified group about which a researcher is interested in. And so if I go back to this slide, if I'm looking at students taking on-campus versus online classes, my population would be every student who's taking an on-campus class, let's just say in the United States, and every student taking an online class in the United States. And it could be any state, I haven't specified, could be college, could be high school. I'm interested, my population is very large. It is everybody. But it's often too hard to study the entire population, right? It would take me forever, and it would be impossible. It would be impractical. It would be time consuming and expensive to study the whole population. So instead, we usually study a sample. A sample is a subset of the population, the part that's in your experiment. So I might take 100 students who are taking an on-campus class and 100 students who are taking an online class, and those will be my sample that I do my research study on. So, and then from my results, I hope to then make an inference, going back to inferential statistics, about all students who take on-campus classes versus all students who take online classes. A random sample is a subset of the population chosen through a procedure that ensures all members of the population have an equal chance of being selected. So this is like a random sample. You would put the names of all students taking an online class and all students taking a in-person class, and their names into like a hat, or nowadays into a computer, and then randomly generate 100 students for each group. That way everybody has an equal chance of being in your study. And by doing that, you hope you're getting a representative sample, meaning that the group that you're studying has characteristics similar to the population. So when I do a random sample and I randomly select students' names, I should have, let's say equal numbers of age and gender breakdown, and people with high IQs and people with low IQs, and people who are highly motivated and people who are not so motivated. That group, because it's randomly selected, should be similar, should be representative of the population. All right. Different research methods, descriptive research methods. These are types of investigations psychologists use to explore a phenomenon. When you use any of these descriptive measures that we're going to talk about here, you cannot determine cause and effect. You need to actually do an experiment, which we'll talk about soon, to determine cause and effect. These are just basically used to describe, descriptive, what's happening in kind of in the real world. So one way we can do a descriptive study is using naturalistic observation. This is going into the real world and just observing what's going on and taking detailed notes or tallies of what's happening. So how many people are using cell phones on a college campus? Well, I could just go to a college campus, sit on a bench, and tally everybody who walks by. Are they using a cell phone? Are they not using a cell phone? Are they using a cell phone or not using a cell phone? This is a naturalistic observation. Do children at a park typically play alone or in groups? So I could go to a park and, again, count how many children are playing alone or playing in groups. Here we've got an animal researcher who's out in the real world, observing subjects in their real environment. Another type of descriptive study would be a case study. A case study is an intensive investigation of an individual. So N means number of people in your study is 1, where there's only one person or one case in your study, and the participant serves as their own control. You don't have two groups, you're just looking at one person. And this is really important and used to study rare phenomenon. or try a new intervention. So if you have a very unique situation, and this is a picture of Jeannie. Jeannie is a very famous research participant. You'll read about her in many books if you take many psych classes. She was found horribly abused and neglected, basically tied to a chair in a basement and not exposed to any language until she was found by the police. I think she was about 10 or 12 years old. And so the question was, can you teach language to someone who is 10 or 12 years old? Typically, we learn language from a very early age as our brains are developing. And so the question was, can we teach language to Jeannie? And so this was a single case study. You certainly don't have 100 children to be in an experimental and a control group, and that's a good thing. You don't want 100 children who have been neglected and abused and not exposed to language. And so all they could do was do a study on just her, one specific case. Or if you're wanting to try a new intervention, a new type of therapy, well, maybe I'll try it with one person and see if it works before I try it on 100 people. Other case studies in action, the Jim twins. This is identical twins who were separated shortly after birth and reunited at age 39. There's some really great videos. You could look up the Jim twins. And we can then study how similar or different are twins who are raised apart, identical twins who are raised apart. And in this case, you can see they were both named James by their adoptive parents. They both liked math and carpentry. Each man, again, they hadn't known each other. They were separated at birth. They met when they were 39 years old. Each man had a dog that was named Toy. Each man had a first wife named Linda. And each man had a second wife named Betty. Now, those are pretty impressive differences. Or is there something about biology? People were trying to study this. They even smoked the same cigarettes. They drove the same type of blue Chevy. They traveled to the same vacation spot in Florida. There were lots and lots of very interesting things that we learned about these two twins. But again, it would be hard to find a huge group of twins, identical twins separated at birth. And so we do a case study. We just look at one set of twins. And we can then learn quite a bit about nature and nurture and the influence on people. Another type of descriptive technique is called the survey method, and this is when we use questionnaires or interviews to gather data. You've all probably taken a survey, a paper and pencil survey, a survey on the computer, or we can use an interview. And this allows researchers to gather a lot of data quickly. We have to be very mindful of how we word questions so that they don't bias people's responses. We also have to be really worried about and thinking about how we get participants to be very honest. And this, you would all learn about how to do this in a research methods class. This really just skims the surface. It doesn't help us understand why people respond the way they do. We would need to kind of do a follow-up survey to understand that. And there are sometimes very low response rates that may lead to a non-representative sample. So for instance, if I were sending out, let's say, a political survey on the computer, well, probably 90% of the surveys go unanswered. And again, you may have had this experience. Someone calls you on the phone and asks you to take a survey and you hang up, or you get a survey in your email and you throw it out. But 10% of the people take the survey. Well, that might be a non-representative group. Who is going to take the survey? Well, maybe these are people who are the most politically motivated or politically interested. you have to think about who is it that actually takes your survey and see if there's anything non-representative about that sample. The last type of descriptive technique would be a correlational method, and this is the degree to which you're looking at the relationship between two or more quantitative, which means number variables. So do your SAT scores predict how well you would do in college? And so I would ask people, what's your SAT score and what's your college GPA? So those are two number variables, and I look to see if I can find a pattern. Or does watching violent TV in terms of the hours of violent TV children watch lead to aggressive behavior, the number of aggressive acts? So again, I'm going to look at how much violent TV, how many hours of violent TV a child watches, and how many aggressive acts, and I'm going to look for a pattern. When we do a correlation, our correlation, we end up with what's called a correlation coefficient. Again, you will learn more about this in statistics, but it's a statistical measure. It's symbolized by a lowercase r, that means correlation coefficient, that indicates the strength and direction of the relationship between two variables. And I'm going to explain this in a second. Your correlation coefficient ranges from -1 to +1. That's it. So it's usually a decimal point. It could be a positive or negative decimal point. The closer your correlation is to -1 or 1, the stronger the relationship between the two variables. And the closer your correlation coefficient is to 0, the weaker the relationship. So what does that mean? Let's look at a positive correlation. Remember I said your numbers can be from -1 to +1. So if you end up with a positive number, 0.32, 0.45, what that means that as one variable increases, the other variable increases as well. So any positive number, you don't even have to look at what the number is. Just so long as it's positive, it means that as one variable increases, the other variable increases. So here I've got years of education and hourly salary, and each dot is a person. And so I've got a person here who has 8 years of education, only went to 8th grade, and they're making $5 an hour. As you can see, this is made up data. And here we have someone who went to nine years of education. They're also making about $5 an hour. But as you go up on years of education, someone who's had 22 years of education, they've gone to graduate school. Well, these people are making $25, $22 an hour. Their hourly salary goes up. So as your one variable goes up, the other variable goes up. That is called a positive correlation. And you can notice that on a scatter plot. That's what this is called. All these little dots is a scatter plot with this upward sloping line from left to right. You could think about some other variables that might be positively correlated, that as you go up on one of the variables, you go up on the other. Now, the strength of a correlation, how strongly those variables are related, that has to do with the actual number, the decimal point. So if it's 0.32 versus 0.78, these are both positive correlations because we can see the upward sloping line. If you have a perfect positive correlation of 1, that means every dot falls exactly on this line. There's no variability. Nothing in psychology ever looks like that. 0.73, this is a little bit less strong. It's not quite 1, it's less than 1. And you can see there's more variability among the dots. You still have a positive correlation. As you go up on one variable, you go up on the other. But not every single dot is on the line. Maybe this is something like hours of studying and grade on a test. Well, in general, the more hours you study, the higher your grade. And that's what it looks like. But here's one person who studied quite a bit but didn't do great, right? It's not perfect. And this would not make any sense, right? This would mean that every time, let's say you studied 0 hours, you would get a 50% on the test. And every time you studied 51 hours, you'd get a 51 on the test. And every time you studied another amount of hours, everything would be perfectly lined up. That's just not how it is with people, right? This is more like maybe something like physics, where you can get these perfect correlations, but certainly not in psychology. A negative correlation, this is when increases in one variable are associated with decreases in the other variable. This is a little bit like brain yoga, because as one variable goes up, the other goes down. So in this case, and you'd notice that on a scatter plot with this downward sloping line from left to right. And this is showing, let's say this is hours of TV and GPA. And what we're seeing here is that the less hour of TV you watch, the higher your GPA. The more hours of TV you watch, the lower your GPA. And again, we've got our dots not on one line. There's quite a lot of variability, and this correlation is negative 0.6. We know it's a negative correlation because they've got this downward sloping line. And 0.6, again, it's not 1. 1 would mean that, or negative 1 would mean that all the dots fall on the same line. There's quite a bit of variability, but we still see a pattern, and that's what we're looking for in a correlation, is a pattern. So again, here's a positive correlation between temperature and amount of beer sold, so that as temperature increases, amount of beer sales increase. And here we have a negative relationship between temperature and coffee sales, that the higher the temperature, the lower the coffee sales. The lower the temperature, the higher the coffee sales. Do you see how that works? And again, none of these are perfect correlations. Perfect would be that every time it's 40 degrees, you always sell 30 cups of beer. That's not the case, but we see a general pattern. When we have a correlation, we say we can't say anything about cause and effect. That you can't say one thing causes the other. We just say we have a pattern. We have a relationship between these variables. And that's because there can always be what's called a third variable. A third variable is some unaccounted for characteristic of the participants that explains a change in the other two variables. So if we have, let's say, a negative correlation between alcohol use and GPA, meaning the more alcohol use by a college student, the lower their GPA. Let's just say we see that. Well, if it's a correlation, all I did was ask people, how much alcohol do you drink a week? What's your GPA? How much alcohol do you drink a week? What's your GPA? Again, I'm not doing an experiment or manipulating anything. I'm just gathering data from the real world. When I do that, there could be a third unaccounted for variable. For instance, there could be depression. That it's when people are depressed, they tend to consume more alcohol. They're self-medicating. And they tend to have lower GPAs because they're depressed and they don't go to class and they don't study. They don't do much. And so we can't say that alcohol consumption causes GPA to go down when we've done a correlation. All we can say is there's an association. The more alcohol someone consumes, the lower their GPA. But there's this possible third variable, and you could probably think of other variables that we haven't looked at that could lead to people consuming more alcohol and having a lower GPA. So third variable is some unaccounted for variable that causes these two things to happen. And we also have the problem of directionality, that you don't know which causes which. If we again have this negative correlation, we might like to think, if I was an alcohol researcher, I might like to think that, well, I found that as people drink more alcohol, their GPA goes down. That sort of makes sense. But it could be that having a low GPA causes people to drink more alcohol. Could go that way too. That having a low GPA, they're stressed out. They're thinking, I'm going to get kicked out of college. My parents are going to be mad. And they start drinking. So you don't know which causes which if all I've done is a correlation where I've just asked people, how much alcohol do you consume and what's your GPA? So no matter how high your correlation or how logical the relationship, you can't say anything about cause and effect. Which brings us to an experiment. This is like the gold standard of research. And when you do an experiment, you can finally say something about cause and effect. This is a type of research that manipulates your independent variable and measures the dependent variable and allows you to say something about cause and effect. In this case, researchers assign participants to 2 or more groups that they try to make equivalent on all other variables with one key exception. One group gets the treatment and one group doesn't. So for example, if I was interested in does watching violent TV cause aggression in children, I could have 2 groups of children that are hopefully similar in their age and their gender and their maybe socioeconomic status. I try to keep everything similar between my groups. But I have one group watch 3 hours of Cops, pretty violent show, and one group watches 3 hours of Barney. This would be a non-violent show. And then after, I measure the number of aggressive acts. So I've manipulated the independent variable here, which is what type of TV they're watching, either violent or non-violent. And then I'm measuring the number of aggressive acts. And this allows me to establish a cause and effect relationship. So we assign people to 2 groups, or I guess it could be animals too. The experimental group, those are the ones who get the treatment. And then the control group does not get the treatment. This is the comparison group. You can see these poor mice. This group is shaking all over the place, and this group says, well, I guess we're the control group. We have the independent variable. This is the variable that's manipulated by the researcher to determine its effect. And the dependent variable, this is what you're measuring, as we talked about before. We often want to do a double-blind study, meaning that the researchers don't know who's in the treatment group and who's in the control group, and the participants shouldn't know if they're in the treatment group or the control group. And this helps avoid bias on the part of the participants and on the part of the researchers. So we often use a placebo group as best we can. It makes a lot of sense in medication, where you have 2 pills, they look exactly the same. One pill is filled with the actual medication, and one pill is filled with something that is like a sugar pill that doesn't do anything. And so when the researcher gives the pills to the 2 groups, they look the same, and the researcher doesn't know who's getting the medicine and who doesn't. And the participants also don't know. And so, if you know you're getting some kind of treatment, let's say it's an anxiety study, and one group knows they're getting the anti-anxiety medicine and one group knows they're not, well, they might change their responses because they just feel as though they're getting better, they're taking the pill, they have an expectation they're going to be getting better. Same with the researcher. The researcher, not because they're trying to be unethical, but they may start to think that they're seeing less anxiety in the group that's getting the actual medication. Kind of subconsciously, they know which group is getting the medicine and which isn't, and so they're kind of seeing things differently. So the best thing is to not let anybody know, the researchers or the participants, who's in what group until the very end. So at the very end, then we would let the people know which one is who got the medicine and who didn't. This is in your book. It's pretty interesting. An experiment, you can read more details. This was the SpongeBob experiment, where they had 64-year-olds who were randomly assigned to watch 9 minutes of SpongeBob or 9 minutes of an educational program, or draw with crayons and markers for 9 minutes. Then they were given a test of executive functioning. This is a test of your frontal lobes, which we'll talk about, like planning and flexibility of thinking. And the results were that the children in the SpongeBob group performed worse. And we can actually say from this very brief study that watching SpongeBob causes people to do worse on an executive functioning test. Research ethics, very important. That doing research carries an enormous amount of ethical responsibility, and there are very strict ethical guidelines which we must follow to protect our research participants. Different professional organizations like the American Psychological Association or the APA has written guidelines. There's actually a booklet that tells you everything you have to do to protect your research participants. Some of the following are in there. You should do no harm. You can't hurt your participants. You have to safeguard the welfare of human research participants as well as animals. So we do a lot of research with animals, and there's just as much ethical responsibility we have to animals. We show responsibilities to society and to the community. We maintain accuracy in our research, in our teaching, and in our practice, and we respect human dignity. The research is carried out and then looked over by what's called an institutional review board, or an IRB. So there are people who are checking in on you. A lot of research is done in universities or hospitals, and all of these places have IRBs that check and be sure that you're carrying out your research in an ethical manner. We provide confidentiality, that we don't use names. Research participants are usually given an ID number, so it protects anyone from knowing. As researchers, we ask a lot of, particularly in psychology, a lot of really personal questions. We ask about your drug use, your alcohol use, all sorts of things. And so we want them to be honest, and we want to be sure that we're protecting their privacy. And so we protect research data from misuse or theft. We keep everything confidential. Informed consent is very important, where we tell participants what their participation will entail. We let them know, this is what we're asking you to do. This is how long it will take. We want to be sure that they're informed about what their participation will entail, and then they actually sign a consent form that they want to be part of the study, or maybe they don't want to, and they don't have to be. And then we debrief at the end, which means we let people know what the study was all about, what was the purpose of the study, if we had to use any deception, which we say like, oh, maybe you've got the placebo or the actual medication. We let them know what group they were in, why we had to not tell them in the first place. And so we give them all the information so they feel really good about participating in the research by the time the study is over. Lastly, we're just going to introduce the idea of positive psychology here. And this is an approach that focuses on the positive aspects of human beings, seeking to understand their strengths, the roots of happiness, creativity, humor. This goes with the humanistic perspective. And with our video that you watched on Sam and Anais, instead of focusing on the fact they spent 25 years apart, positive psychology would focus on looking at how happy are they now that they're reunited, helping other twins, helping other adoptees, things like that, focusing on the positive. All right, well, we finished that chapter. Thank you very much.